So basically today, here's what's we are going to start with chapter 3, but I want to tell you why. So if you guys have your books in front of you, you had your introductory pages, you even see a formula page, right? Right at the very end before we get to that first page of chapter 2. We'll get to that formula page later on. But when you take a look at chapter 2 and we start to go through chapter 2, do you see how chapter 2 is very visual? It's a scatter plots, it's filling out graphs and so on, and we go all the way through chapter 2. And instead of me doing this in class with you, where it's very visual and not too bad to understand, I'm going to save that for the following week when you guys are completely online. So I'd rather do that when you're online, like an online meeting like right now, as opposed to in class and then try to go over chapter 3 with you online because it's a little more difficult. So if you keep going all the way to where you get to that next green page, and it should say chapter 3 polynomials. It's a green page. Now, Connor, Luke, and Heidi, you won't have that green page. I put those in mine. Mr. Smith doesn't have it, but you should get to the very front where it says 3.2 work with exponents. Okay, so do you guys have that? Whereas the rest of the class, the other 21 of you, you have that nice green colored page with 3.2 working with exponents as the first part. Give me a thumbs up if a hand in the air there if you're at that green page saying chapter 3 polynomials. Okay, I'm going to wait for everybody with their hand in the air except those 3. So when you scroll through, go by chapter 2 and go to chapter 3. So Carson and Braden, do you guys have that? Braden, now Carson. It's just Carson to make sure he has it.
Yes, I do have it.
You got it there. Perfect. Okay, everybody can put their hands down. Now, every chapter, and again, Connor, Luke, and Heidi, you guys will see this on Monday or Tuesday when you're in class, okay? But every chapter I put a green page, and notice there's a spot for your homework. Okay, so what you can do right now is, do you see on my screen right here, page 114, questions 1 to 10? Do you see on my notebook page here that you guys can view? Yeah. You might as well write that in for your homework under 3.2. So you can see right here, 3.2, and here's the homework for 3.2. So page 114, 1 to 10, you will get to that later today. All right, but at least you write it in and you've got that there. Now, what I would do if I was you guys is I would always write my homework on that front page. Every time we go through a lesson, I'll try to remind you, but put your homework there. And when you get that homework done and you understand it, put a check mark next to it and you know you're good. Any question that gives you trouble, circle it or make a little note of it. And then when you're in class, I can go over it with you or help you out and so on. So we are going to start with 3.2 exponents. So if you guys turn the page, you should see, and I'm going to cover myself now, you guys should see a page that looks like this. Right here. Do you guys see this page? Yeah. Even you guys, Connor, Luke, Heidi, you guys should see this also, okay?
Yeah.
Sorry, I can't see you.
I turned myself around, so you don't need to see me anymore. You just need to see my smart board.
Sir,
is that good?
Can you hear me?
Oh, yeah, I see it.
Okay.
Sir, I don't know. Can you hear me?
So just make sure if you're not talking, Kuwar, your mic seems to go off a lot. Okay, so if you can mute your mic if you're not talking, it seems to, yesterday it was going off a lot too. Is that okay, bud? Oh, I think you did. So, all right. So let's take a look at this lesson. But before we get there, I'm just going to do a little intro here, okay? I'm going to have a little chit chat with you guys because I don't know if you know or not, but last night I called every one of your parents and I talked to them about the course and I talked to them about how it was going to go and everything else. And for the most part, they were very, very on board. They like the fact that you guys are going to be responsible to get some work done in the morning and have to submit it. They like the fact that you've got to get into a routine, which was really, really cool. And then I just started talking to them, you know, your parents in general. And it seemed like there was a growing trend, and I couldn't believe it. As I was talking to your parents more and more and more, there seemed to me this trend, and I kind of summed it up right here. Not everybody, I don't want to put everybody in this category, but a lot of them were a little bit frustrated with the fact that you don't do anything around the house. You don't clean your room, you don't do the dishes, and you definitely don't take out the garbage. A lot of you aren't pulling your weight around the house, and I was disappointed to hear that. You guys got to help out around the house and so on. And having this conversation with your parents, I kind of said, well, can I help somehow? And they said, well, I don't know what you can do, sir, but if there's any way. I said, well, here, what if we did this? I said, what if we give your son or daughter a little bit incentive in order to do some work around the house and to chip in, because I mean, it's their house too. So after talking to them, we came up with this plan, and I contacted your parents, and every single one of your parents is on board with this. They've all agreed to it. They've signed a contract. And here's what it is. They have decided to give you an incentive to help out around the house. And they're going to give every single one of you one of three options. Okay? So this used to be in October. This should be November. Okay? So obviously we're in November. So let's actually make it the start of December. So you don't have to copy any of this out, by the way, okay? I just want you kind of listening here. So we're going to make this for the month of December. So starting December and all the way till the end of December, you guys are going to do all of the chores, everything around the house, all of the chores. So you're going to clean up your room. You're going to clean up the mess from dinner. You're going to take out the garbage. You're going to dust and vacuum and take the dog for a walk. You're doing everything. But here's what your parents have agreed to, and I'm not lying to you here. Here's what they've agreed to. Your parents will give you three options, and here's the very first option. They will give you $10,000 at the end of every single day. True story. I'm not lying to you. Okay? I'm not lying to you here. Well, maybe I am, but $10,000 at the end of every single day. So you do the garbage, you dust, you vacuum, you make dinner, you clean up, you walk the dog, and at the end of the day, your parents go, here's $10,000. And they'll do that every single day for December. Sound good so far? Give me your hands in the air if that sounds good. All right. Well, there's more options though. So here's the second option. On the very first day of you doing all of the work, you do everything in the house. You dust, you vacuum, you take the dog for a walk, everything. What they're going to do on the very first day is say, congratulations, here's 1 penny. And you go, okay, great. The very next day, you do everything again. You dust, you vacuum, you take out the garbage, you walk the dog, you clean up the dog's mess in the yard. You do everything. Make your bed, clean the room, you clean the basement. Here's 2 pennies. And the next day is 4 pennies. The next day is 8, and so on. Okay? Or option 3 is you have to do all the chores for the entire month, and you do not get paid till the very last day. But on the very last day, your parents will give you a one-time payment of $600,000. You don't get paid anything on day 1 or day 2 or day 3 or day 4. You have to keep doing everything. You can't miss. And on the very last day, once you get done all those chores, they say, thank you so much. Here is $600,000. So here's what I want you to do in the comment section. All I want you to do is write your number. Would you take option 1, option 2, or option 3? So in the comment section, just type what number you would take. Give you another 30 seconds here for everybody to get an answer. So which one would you take? I'm looking at these answers here and I'm seeing a pretty good mix of answers. I don't see one more than the other.
Sir, you said a month, right? Just all of December?
Just December, 1 month. You can reevaluate after that. Okay, we're all over the map, which is awesome. Now, can somebody tell me why they would pick option 3? Let's get a couple people unmiking and saying why in the world they would pick option 3 here. What would be the incentive with option 3? I see Connor, I see Ashton, I see Madison. Mateo's on the fence with 2 or 3. Emily, Heidi, Manveer, Jack. You guys have all said option 3. How come? 1 or 2 of you at least let me know why you would pick option 3, a one-time payment of $600,000. Even Paula had just kind of piped in here with 3. Anybody want to kind of unmic and tell me? Maybe somebody
I
do.
went 3 because I tried to do the math and it just seemed like there was the most at the end of the month.
Yeah, I at first glance I agree with you, Connor, for sure. Anybody else?
10,000 a day seems like a lot, but once you add it up, 300 or 600,000 is the most.
Yeah, definitely 600,000 is definitely more than this if you do the chores for the whole month. Now, what would be a drawback from 3? The only drawback I would see from 3 is if you end up messing up along the way, you don't get any money. So at least in option 1, you do it for a week and you get paid 10,000 at the end of every day. At least with option 1, if you mess up, you at least get some money out of it, right? Did anybody want to talk on option 1? Why would you pick option 1? So Tasby, who else here? Caroline, Ella, Melina, Adriana, Ashton. You guys have all said 1. Why would you pick 1? Anybody want to unmic? Let me know.
I said 1 because I didn't know, like I didn't do the calculations in my head yet because I thought that would have equaled up or been a bit more than 6,000 at the end of the month.
Okay, so say that one more time.
I picked 1 because I thought it would have been more money than option
Okay.
3, but
So would you switch your option now to 3 if you could, Ashton?
yeah, I would.
You would switch it to 3. Anybody else want to talk on 1? Why they would pick 1? Don't be shy. Nobody? All right. Let's talk about 2 then. I do see some people picking 2. I kind of put it in as a little bit of a joke, I'll be honest. But some people are picking 2. How come you're picking 2? What made you entice for 2? That was kind of a joke on my part.
I picked
Or
2
was it?
because doubles
Or
up
was
every
it?
day.
What's that?
I picked 2 because it doubles up every day.
Yeah, but even like, to 4 pennies, to 8, to 16, to 32. I mean, if we take a look at this a little further, okay? If I can scroll down here, I did this originally with the month of October because we did this the very first part of our course instead of December. So let's just assume that this is December, okay? So if everybody's watching here, so what if we did do all the chores on the very first day on this first Thursday of the month, and how much do we get paid? 1 penny. And on the very second day, you do all the chores, everything's done, you get paid 2 pennies. And then on the next day, 4 pennies. And then you get paid 8 pennies. And then you get paid 16 pennies. And then you get paid 32 pennies. And then you get paid 64 pennies. And oh my God, the 8th day is a big, big day, because guess what? You made 128 pennies. That's $1.28. Congratulations, you just did a whole week's worth of work and you got paid $1.28 on that day. This doesn't seem like too much money, to be honest. Anybody want to talk again on this?
Well, if you keep going, like to the end of the month, to the 31st, it's gonna be a lot more.
It's going to be a lot more. Well, let's do this a little different way. Everybody kind of watch here, and here's where we're heading into our lesson today. I am going to change these numbers, and I'm going to do them in red, okay? So my I'll go to the second day because it's easier. I'm going to write each of these as a power of 2. 2 to the power of a number. And in this particular day, the green 2 can be written as 2 to the power of 1, correct? Is everybody okay with 2 being written as 2 to the power of 1?
Yeah.
So now when I take this, I'm going to clone it. I'm going to go to the next day. 4 isn't 2 to the power of 1. 4 is 2 to the power of 2. I'm going to clone this again. I'm going to bring this over here. 8 isn't 2 to the power of 2. It is 2 times 2 times 2. So 2 times 2 times 2 is 2 to the power of 3. 16 is 2 to the power of 4. 2 times 2 times 2 times 2. Don't go 2 times 8. 2 times 2 times 2 times 2. How many times do you have to multiply 2 by itself to get to 16? And if you see the pattern going here, the next one is 2 times itself 5 times. 2 times itself, whoop, get back here. 2 times itself, this is 6 times. And even if I went to the next one, clone, I went here. You can see on my calculator, if you just watch here for a second, 2 times 2 times 2 times 2 times 2 times 2 times 2. Do you see how that's 7? I hit enter, and do you see how I get my 128? Or I could have used this key right here on my calculator, that X with a little white box up top. I could say 2 to the exponent 7. And when I hit enter, it will do 2 times 2 times 2 times 2 times 2 times 2 times 2, and there's 128. Is everybody okay? So, that being said, I want you to look at this calendar, and I want you to look at the following. There is a relationship between the following. So let me get my highlighter here. There is a relationship between the day of the month. Do you see that day of the month up in the top corner? There's a relationship between the day of the month and, I'll do this in blue, the power on our exponent of 2. How do we get from the green highlights to the blue highlights? If I were to tell you what the green highlighted number is, how would you get to the blue highlighted number? Any ideas? If I were to tell you what the green highlighted number is, so here's what I'm kind of saying. Do you see right here? If I were to go to this day right here, how do I know what the power is on that 2?
-1.
Does everybody see how it's -1? Every one of these, my day is 2, I go down to a power of 1. My day is 3, I go down to a power of 2. Do you see how I'm always subtracting 1 from the green highlight to get to the blue? So I'm going to change this. This would be 2 to the power of 20. But what I'm more concerned about is, what about this very last day? What would be the power on this very last day? 2 to the power of?
30.
30. Is everybody okay with how they see 2 to the power of 30? Everybody okay with that? So I grab my calculator, and I'm going to go up here, and I'm going to say, well, wait a second. The very last day, my parents are going to pay me 2 to the power of 30 pennies. So when I hit enter or equals on my calculator, take a look at how many pennies I'm going to get paid on my very last day for doing all of this work. That's a real big number. If I were to copy this number out to the side here, 107, or sorry, 10, 373, let me go to the next one, 737 418. So let's go 737 space 418 space. And the reason I'm breaking it up like this is on the end we've got 0.24. So I'm going to put decimal 24. What I just did was I divided that by 100. And by dividing by 100, I've switched this from pennies to dollars. On the very last day of the month, for dusting, vacuuming, taking the dog out for a walk, cleaning the basement, your parents will pay you $10 million to do that. Isn't that incredible? So the very first day, you've got 1 penny, 2 pennies, 4 pennies, 8, 16. That last day that we showed up here, you got $1.28. But if this keeps going like everybody was saying, and you keep going week to week to week to week to week, this very last day is over $10 million, which does not include the $5 million right here, or the $2.5 million right here, or the $1.25 million right here. Do you see how quickly this escalated, starting how big it actually got to here at the end? At the very end, your parents are going to be paying you close to $20 million to do the chores. So if I go back up here, does anybody want to reconsider which option they would have? 600,000, 310,000, or close to 20 million? I think most people would probably switch and go, give me 2, because I didn't really realize how quickly that was going to escalate. Hands in the air if you followed that little bit of kind of a fun activity here. By the way, I did not talk to your parents, in case you're wondering. Was everybody okay with that part? Today, we're going to be looking at exponents and how powerful these exponents are, okay? When we do repeated multiplication, things that get repeated over and over, this would be 2 times 2 times 2. In my calculator, I would have to do this. 2 times 2 times 2 times 2 times 2 times 2, 30 times in order to do that. But it's way easier to go 2, exponent key, 30. Do you see how quick that was? And I get my number. Exponents are very powerful. So here's what we're going to do. We are going to move on to this page right here. So please have this in front of you. Please chime in if you have any questions. But what you are now going to do is you are going to write out everything that I'm showing you on this page into the spots on your page, okay? So that being said, powers or exponential numbers are a great way to show repeated multiplication. So when you show something being multiplied over and over and over and over, that's a great way to use exponents. So for example, 3 times 3 times 3 times 3 times 3 times 3. This is called our expanded form. It shows all the 3's being multiplied together, but when we wrap it up into this nice, neat exponential or power, this is called our exponential form.
Excuse me, sir.
Yes.
Yeah. You told me not to write on my paper. Do you want me
You
to
can
write?
go ahead and write on these. I'll switch them out with new ones once we change the booklets, okay? So you can go ahead and write on these, no problem.
All right.
Okay. So when you have this exponential number, the bigger number that's your base, that's out front. So we call this our base. The exponent written a little bit smaller and kind of as a superscript, it's up top. That's called our exponent or our power. Okay. But what we have to make sure is when we're doing these exponents, we just have to make sure we understand where they fit when it comes to BEDMAS. So when we go with BEDMAS is a way for us to figure out mathematical expressions or equations in the logical order where everybody gets the same answer. When you have more than one operation, you've got to go through these operations in the right order. And the very thing we do is we scan our whole expression for brackets. Are there any brackets that we can solve first? Once we look and we get all the brackets solved, We then say, are there any exponents? And this is why I put it in blue, because we are now dealing with exponents. This is where they fit in the hierarchy. As soon as your brackets are done, get rid of the exponents. The next two are division and multiplication. And the thing is, these two are on the same hierarchy, okay? So they happen in the order that they occur. You don't always do division before multiplication. If multiplication occurs first in your expression, you do that one first. And then the last two, addition and subtraction. This should be nothing new to you, but it's just a little refresher. And again, addition, subtraction in the order that they occur. All right, when you get that chart done, just raise your hand. All right, I see most people done here. So the next thing is, what do you do with a fraction? So up here, it was easy to see that 3 to the power of 6, right here, 3 to the power of 6 is just 3 times 3 times 3 times 3 times 3 times 3. But what do you do if there's a fraction as your base? So for example, what do you do if it's 3/4 raised to the power of 3? All you do is you just raise both your numerator, which is the top, and the denominator, which is the bottom, to that exponent. And I'll show you with this example. By the way, how is the video going? Is it choppy on your end, or is it pretty well, like, is it running smooth, or is your video chopping all over when you're watching me wipe away stuff and everything else? How is it going out there? I just want to know.
It's pretty good. It just chops sometimes, but not much.
It's
Chops a
pretty
little bit.
good.
Senna, what do you think there?
I think it's pretty good. It's not very choppy for me.
Okay, anybody else? Probably depends on your internet connection too.
Mine's very choppy, but I have really bad internet, so.
Okay, that's probably what it is. Are you still able, Ron, to get the gist of everything?
Yeah, for the most part.
Okay. So let's keep going then. So notice here, it's 3 to the power of 4 raised to the power of 3. It's not just a number, but it's a fraction. So what are we going to do here? This 3 is going to say, okay, you get raised to the power of 3, but then you also get raised to the power of 3, both the top and the bottom. So I can write this as 3 to the power of 3 over 4 to the power of 3. Do you see how we followed this rule right up here? Just raise both your numerator and your denominator to that power. Well, 3 to the power of 3 is just this, 3 times 3 times 3. And 4 to the power of 3 is just 4 times 4 times 4. So when we multiply those out, I end up with 27 up top, and I end up with 64 down below. Now, if I were to have this question for you in homework, 3 over 4 raised to the power of 3, I would hope you would show me this step right here. Show me both being raised to the power of 3, but then you can take your calculator and go 3 to the power of 3 and get 27, and you can go 4 to the power of 3 and get 64. So what I have here is just something to show you that this is not needed. That red rectangle is not needed in your solution. You can go right from here all the way to your final answer just using your calculator, okay? Is everybody okay with that? Give you a second to copy that out, and then I want to show you something here. I so wish you guys had your calculators. I wish you had them at home, because I wanted to show you this right here. With this calculator, there's a really neat function here. So I'm going to kind of clear this. Now, if you just watch for a second, once you get your calculator next week, you will be able to open up a bracket right above the 9. So we'll open up a bracket, and do you see how our bracket, inside our bracket is a fraction 3/4? This calculator has a fraction key, which is right here. It's 2 rectangles, one up top, one down below. This is your fraction, and look what happens in your display when I hit this. Do you see how a fraction opens up? Up top is 3, and then I'm going to move down using my keypad, and I'm going to now put my 4. But my cursor is blinking at the bottom, so what I have to do is I have to scroll across. Watch where the cursor is blinking right now after the 4, and as soon as I hit this button, do you see how it's now at the end of the fraction? It was down there before. I'm just going to put that fraction. There it is. Do you see how it's at the 4? And now when I hit across, it goes to the end of the fraction right in the middle. I can now end my fraction. And do you see how I've got brackets around the 3/4? Now, this calculator does have a key designated to cubing, which is right here, x to the power of 3, x to the power of 2, and x to any power. We usually use x to the power of 2 and x to the power of 3. So I'm just going to hit this one. And when I hit enter, do you see how I actually come up with the exact answer we found? 27/64. 27/64 is our final answer. Because they gave us a fraction in the question, I would expect you to give a fraction in the answer. But right above these 2 orange keys, do you see this key that says S to D? It changes it from standard, which is 27/64, to a decimal. The calculator will go 27 divided by 64, there's the decimal. I hit the SD again, fraction, decimal, fraction, decimal, and it will always convert between the 2. All right? So just as another note, everybody's really familiar with a half. 1 divided by 2. When I hit equals, do you see how it gives me a half? 1/2, S to D, 0.5, back to a half, 0.5, back to a half. This will keep changing between the decimal and the fraction. Is everybody okay there?
Yep.
All right, now, watch out for brackets. Okay, not brackens, but brackets. Watch out for brackets. Notice the difference between these two questions. One is -2 in brackets to the power 4. The other is -2 to the power 4. And this is why I want you to watch out. I'm going to grab my calculator again. I'm going to go to my calculator. I'm going to say, okay, bracket. This is my negative key right here. It's an embedded key that you use for negatives. And since I have a -2 right here, I'm going to use this negative key, and I'm going to put -2 and end my bracket. I'm then going to raise this to the power of 4. And when I do that and hit enter, I end up with an answer of 16. Is everybody okay with that first one? But the second one without brackets, if I go back and I say clear, negative, I put my 2, and then I hit my exponent key, and I put 4, I would expect to get the same answer of 16. And when I do, I get an answer, I get an answer of -16. Well, what gives here? Why is it when I have brackets, I get a positive 16, and when I don't have brackets, I get a negative? The calculator doesn't lie. We entered it exactly like we saw it. So let's see why. What is it I'm raising to the power of 4? What I'm raising to the power of 4 here is -2. That's what's in the brackets. So it's -2 times -2 times -2 times -2. That's what's being multiplied 4 times. So -2 times -2 times -2 times -2, when I go in my calculator, that gives me an answer of positive 16. Is everybody okay?
Are we writing that down?
Yes, write that down on your page, okay? And now here's where you've got to be a little bit weary, okay? What this is right here, believe it or not, in expanded form, and I'll just write it above, and you can write this if you want, if it's going to help you, by all means. Here's what this actually is. Do you see that negative out front? Do you see the negative in front of 2? What's actually happening is we're going 2 times 2 times 2 times 2, 2 to the power 4. But that negative out front is actually like a negative 1. So this right here in expanded form can be written like this. This can be written as negative 1 times 2 to the power of 4. Does everybody kind of see how this right here can be written as this? That negative is just a negative 1, but we don't need to write the 1. We can write it a little more precisely by getting rid of the 1 times because it doesn't change the value of 2. But this is technically what negative 2 to the power 4 is without brackets. The only thing being raised to the power of 4 is the 2. And I'm going to cover this up right here, just so you see that. What is being raised to the power of 2, or sorry, to the power of 4 is the 2. Come on. Even my computer's slow there, Ron. Just need to get my whiteout pen. There it is. So my whiteout pen. That's what's being raised to the power of 4 is just the 2. And once we raise all that to the power of 4, if you see the 2 times the 2 times the 2 times the 2, we bring this negative back in, which is just like a negative 1. It changes the sign. So 2 times 2 times 2 times 2 is 16, but we have this negative hanging around, and that's why the calculator gave us a negative, because the negative is not inside the brackets, and the brackets are what's getting multiplied. The negative is inside the brackets here. It's included in all the repeated multiplication. The negative is not inside the brackets. It doesn't get included. Okay? Give me a hand in the air if you kind of understand those two. If it's inside the bracket, you include it. If it's not inside the bracket, you don't include it. Brackets are like cupping what you want to raise to that power. Okay, perfect. Most of you are saying that. Is everybody good with the first page? All right, you can put your hands down there. I just wanted to make sure. Let's go to the second page, and I'm going to get you working for a little bit here. Second page. I want to review really quickly how you guys deal with operations with fractions. You've dealt with this, okay, before in grade school. You've learned about this, but I want to refresh. The 4 main operations besides, and I'm just going to go back a page, besides being raised to a power, like we just learned right here, we know how to raise a fraction to a power. We just have to know again how to add, subtract, multiply, and divide. Adding, subtracting are very, very similar because you need to find that common denominator with each. You add or subtract the numerators, but notice you keep the denominator. That makes complete sense to me because what's the value in finding a common denominator if you're not going to keep it? When you find a common denominator, they're both the same, so that means you don't have to choose which denominator to keep. You just keep the one now that's the same. So it makes sense to me. So when I see 2/3 and a quarter, and again, a lot of people use pizzas as examples. So you've got left over and you got a quarter of a pizza left over. How much total pizza is left over? Well, we can't add 2/3 and a quarter because the denominators are different. So we find our common denominator, which is 12. So I want to write each of these out of 12. And the first one, I have to multiply 3 by 4 to get that 12. So I've got to also multiply the 2 by 4 to get 8 up top. 2/3 is the same ratio as 8/12. And if you don't believe me, I'll grab my calculator here.
Excuse
And
me,
I will
sir.
say-
I don't have that paper.
What's that?
I don't have the paper.
Oh, shoot. Okay, this is one of the ones you're missing here. I will send this to you as a copy. So Connor, Luke, and Heidi, I will, as soon as this lesson's done, just follow along, but I'll make a PDF and I'll send it to you so you can either print it or copy it out, or you can get it when you come next week, okay?
I have the paper.
You do have it?
Yeah, it's
you
on
may-
the back side of the one we did.
Take a look on the backside, Connor. Do you have it there on the backside?
Yeah, I got it.
Okay, perfect.
Paper. I was like,
All good. So now, just take a look here. Do you see 2/3? when I go 2 divided by 3, what I get is 2/3 or decimal 6 repeating. So again, 2/3 or decimal 6 repeating or decimal 666 all the way till they round. When I go 8 divided by 12 and I hit enter, do you see how it reduces down to 2/3? They're the exact same fraction. Decimal 6 repeating. These are the exact same. 8 over 12, 2 over 3. So we take the next one, 1 over 4. We multiply 4 by 3, so I have to multiply the 1 by 3. When I take 8 and I add 3, I get 11 up top, and I keep the denominator, which is 12. So when you have 2/3 of a pizza and you add a quarter of a pizza, you have almost one whole pizza. You have 11/12 of a pizza. You almost have a full pizza left over. Everybody good with that? The only difference with subtracting, we still get our 2 common denominators, but you see the difference between is there's a subtraction. So now we just go 8 take away 3, and we have 5/12. So adding and subtracting, you have to find a common denominator, okay? Multiplying in my eyes is the easiest because you don't have to find a common denominator with multiplying. Multiplying is just 2 times 1, top times top, multiply the numerators, you get 2, and then bottom times bottom, and you get 12. So you multiply the tops, you multiply the bottoms. The only thing that you can do here is you can say, well, wait a second, 2 over 12 can actually reduce down to, and I'm just going to create this here. I've got an equation editor in my notebook. So I'm going to open up a fraction, and I'm going to say, well, wait a second, 2 over 12 can just reduce down to 1 over 6. And now I can put over here that this is equal to, sorry about this, I wish I would have did this ahead of time. This is actually equal to just 1 over 6. And I'll sneak that into there right there. So we can reduce that down to 1/6. Always nice to put your fractions in lowest terms. Everybody good there? And lastly, with division, when you have 2 fractions that are being divided, which is very, very rare in real life, believe it or not, it's hard to find a real life example that you divide 2 fractions, but we do need to know how to do it. The nice part is we don't have a whole new set of rules for division. We just go back to what we know with multiplication. But you take your first fraction and keep it. You change your division to multiplication, and you flip. It's called the reciprocal. You flip the second fraction. So 2/3 divided by a quarter is the same as 2/3 times 4 over 1. And when we multiply this out, it's top times top over bottom times bottom. Now, we have an improper fraction. The numerator is bigger than the denominator. We ask ourselves, how many times does 3 go into 8 without going over? And it can go in 2 times because 1 3, another 3 gives you 6. This will go in 2 times. So when this goes in 2 times, we go 2 times 3 is 6. There's 2 of those thirds left over. So 3 goes into 8 2 times, 2/3 left over. Does everybody remember doing that in grade school? Changing impropers to mixed?
Yep.
Yes.
Okay. And those are the 4 operations. So we may see those, in some examples going forward. Let's just finish up with a couple examples and I'm going to get you working here, okay? So notice each of these says evaluate each expression. So you guys should have these. We're going to go through these together. You'll have plenty to do on your own. The very first one is 3 squared, take away 2 to the power 3 plus 1 to the power 4. You revert back to bedmass. And you ask yourselves, are there any brackets? Do the brackets first. Then are there exponents? Do the exponents second. Then division, multiplication, then addition, subtraction. I look and I scan this and I say, are there any brackets to do? My answer is no. Are there any exponents to do? My answer is absolutely. 3 to the power of 2. Please don't put 6 there. It's so easy to go 3 times 2. It's not. It's 3 times 3 2 times. So we have 9. We then subtract. 2 to the power of 3 is not 6. 2 times 2 times 2. So hopefully you've got some calculator or your phone you can use today. 2 to the power of 3 is 8. And 1 to the power of 4 is not 4. It's 1 times 1 times 1 times 1. And it doesn't matter how many times you multiply 1 by itself, you get 1. You just went through BEDMAS and did all your exponents. So now we go multiplication and division. I don't see any. We go addition and subtraction. So 9 take away 8 is 1, but then we can add 1 and we get our final answer of 2. All right. Everybody good with that one? View, zoom. I'm going to blow this up a little bit here for you. So first one done. And now my computer slowed down. Give me 1 sec here. We'll go to the second one. We scan the second one. We ask ourselves, are there any brackets? Because BEDMAS says to do brackets first. Well, there is right here, 7 take away 5. Inside this brackets, there's an operation for me to do. So 7 take away 5 ends up being 2 inside the brackets. This is being raised to the power of 4. I then have take away 2 to the power of 3. But in this bracket, I don't want you to change this to a decimal. That's not the purpose of that. We have a half, so let's just keep a half inside the bracket. It's just like a number, a half. Don't worry about dividing that and getting a decimal. We're not going to deal with decimals here. So now we have to get done with our brackets. We are now going to move to exponents. There's nothing more I can do in this bracket, and there's nothing more I can do in this bracket. So I'm going to go 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. Take away 2 to the power of 3, which is 8. And now let's remember how we tackle a half raised to the power of 2. If you remember, we take the numerator and raise it to the power of 2, and the denominator and we raise it to the power of 2. Both of those get raised to the power of 2. So when we figure this out, here's our next step. Showing our work for somebody to mark this, we want to show each of our steps. So going through, just give me a second here, computer's slowing down again. Sorry about my magic pen there. I get 1 to the power of 2, 2 to the power of 2. 1 to the power of 2 is 1, 1, and 2 to the power of 2 is 4, 2 times 2. Please raise your hand if you're okay moving from this to 1/4. Just raise your hand if you understand that step. 1/2 squared goes to 1/4. Because real quickly, just if you want to watch here, 1 over 2, and I'm going to highlight this and put brackets around it. Where are you, brackets? Right there. Oh, I got to move this inside. So I'm going to get rid of this. So when you have this right here, 1 over 2, and this is now to the power of 2. This is equal to, we have a fraction again. This is 1 to the power of 2 over 2 to the power of 2. Do you see how that 2 goes into both? Which is actually, okay, there it is, sorry. This is actually up top, just in a really expanded form, 1 times 1, and down below is 2 times 2, and then you can see how we get to 1 times 1 is 1, and 2 times 2 is, whoop, no, 2, but 4. Everybody see how we get there? This is the long, drawn-out way to do it, but you can go right from what they give you. There it is. So you can go right from what they give you right to 1/4, okay? So that's how we got from 1/2 squared to 1/4. This is the operation right here. So now, what do we have to do here? Well, we've got 16, we've got 8, and we've got 1/4. We have to find a common denominator. We've got a fraction here. You've got to understand that 16 is just like 16 over 1, and 8 is just like 8 over 1, but we don't have to write the 1. It doesn't make the numbers precise. We don't need dividing by 1, so we usually don't write them. So that's why they're going to go away. But when we figure this out, we've got to put every single one of these out of 4. Out of 4 and out of 4. We already have this one out of 4. We've got to get each of these out of 4. So we multiply the 1 in the bottom by 4. We have to multiply the number up top. 16 times 4 gives us 64 over 4. 8 times 4 gives us 32 over 4. And then we have this 1 over 4. Now we have a common denominator. We keep the common denominator, which in this case is 4. And what we say is 16, take away 32, plus 1, leaves us with 33. Is everybody okay with that one? Hands in the air if you followed that one there. You will have a little bit of time to practice this, okay? Just want to make sure that everybody's okay with this. I'll give you a second to copy it out. We'll move on in about 30 seconds here. All right, now, if I gave you this right here, and one of the nice things about the magic pen, if I give you this right here and only this, and if I said evaluate this, you can't do anything. Okay, so if all they gave you was x cubed minus 9x squared plus 27x minus 27, I said evaluate that, you would look and say, well, sir, I don't know what you want me to do with that. I don't know what I can do. It's not like I just have numbers. There's letters in there. And your answer is exactly right. But when I get rid of this and I say evaluate this when x is equal to 3, now we're in the ball game. X right here, you can say thank you very much, x, but you're gone. And in your spot, I'm going to put a 3. Thank you very much, x, but you're gone. Thanks for holding that spot for me. This x, say thank you to it, but it's gone. Each of these x's leave, and in the spot goes a 3 because we said x is equal to 3. I would just caution you, put brackets around your number when you plug it in. So when I go over to here, here's the very first thing I need to do here. I need to get rid of the x, and I need to put in a 3 in brackets. Do you see how it's 3 cubed, not just x? Put brackets around your number. I then subtract. I have 9. Open up a bracket, put in my 3, and end the bracket. Power of 2. This x now became bracket 3 and the bracket. Plus 27 times, open up a bracket and put 3, and then minus 27. Now we can evaluate this. All right, we go through BEDMAS. We say, is there anything that we can do in the brackets? Is there anything we can do inside the brackets here? Anybody want to help me out here? I know some of you are probably just copying out that step, but is there anything we can simplify in the brackets like we did right up here in question B?
You can put them to the power that's like given.
Exactly. We can definitely raise them to the power, but just inside the brackets, is there anything I can do like this one here, 7 take away 5 in the brackets? Not yet. There's nothing I can do inside the brackets to simplify. And Connor just piped up and said, well, sir, you can't do anything inside the brackets, but you can definitely raise each to the power. And that's our next step. 3 to the power of 3. So hopefully today you can use your phone or a calculator at home or something just for today until you get that calculator that I'm going to get you. 3 to the power of 3 is 27. Take away 9. 3 to the power of 2. I guess I did 2 steps at once here. I wish I didn't. This right here just works out to be 9 bracket 3 squared is 9. So 9 times 9 gives you 81. If I were to put 1 step in here, and I'm going to, okay? Just going to undo that for a second. I know some of you can do this, but I don't want to lose anybody here. The one step that I could put in there right here is I can say 3 to the power of 3 is 27. And then I go subtract 9. And 3 to the power of 2 ends up being 9. So I'm going to keep the 9 in the brackets. I go plus 27. And I open up a bracket. I just have this 3. And then I go minus 27. This would be what I would put as an intermediate step, just so I don't lose you with the brackets. So if I had to put another step in there, I just want you to understand that 3 to the power of 2 is 9 right here. And then 9 times 9, that's how I got my 81. Is everybody okay with that right here? The 9 times the 9, and that 9 in the brackets is 3 squared. 81, 27 times 3, and then minus 27. So this...
Sir, is a number and then a bracket always multiplication?
Always, always, always. That's a great question, Connor, and I get that addressed in class all the time. When you have a number and a bracket next to a number, this always means multiplication. You multiply those two together. 9 times 3 squared, do your 3 squared and get 9, but then 9 bracket 9 means multiply. Always, always multiply when two numbers are together with brackets, okay?
Sir,
Yep.
so in the first equation, it said 27. Where did you get 9 and 9 bracket 3 at the exponent of 2 out of 27?
Right here?
Yeah.
Well, that's not 27. 3 squared gives me this 9 right here, and 9 times 9 gives me the 81 right here. This 27 is already given to you right here. It was in the question. Does that make sense?
Oh, yeah. Sorry, I didn't see that.
So if I could do this with colors, this x cubed in blue became 3 cubed, which worked out to be 27. But then this take away 9x squared is take away 9 3 squared, which was take away 9 times 9, which was 81. Take away the 81.
Sir, why is there 281s though? Sorry. Is there...
The reason there's 281s is you see the 9 times the 9 right here?
Yeah.
That's 81. And 27 times 3 right here, this is also 81, believe it or not.
Oh, okay.
Okay? And
Yeah.
then we go to our last one, and this minus 27 is just kind of along for the ride. There's nothing really to do with it. Just along for the ride, and I'll put the blue here. Does everybody see how the colors just made their way down? So this right here, minus 9x squared became minus 9 3 squared, but 3 squared in BEDMAS, that's what I have to do first. 3 squared gives me a 9, and then this 9 is 9 times 9, which is 81. 27x is 27 times 3 because x is equal to 3. We put the x in for the 3, or the 3 in for the x, sorry. 27 times 3 is 81. And when we actually add all these together, 27, take away 81, plus 81, take away 27, I'm sure some of you have already done it at home. Are you guys getting an answer of just 0? It makes sense. It makes sense because look, I've got a positive 27 and then I take away a 27. Those go away. I got a positive 81 and then I take away an 81. Those go away. All right. You guys try this one. Plug in for A and plug in for B. Solve and see what you get here. Okay, and I'll take this up in about a minute.
Sir, do you want the answer once we're finished?
Just figure it out. I'll show you the answer in about 30 seconds here, okay?
All right.
All right, first step. Thank you very much, A, but I now know what you are. You're a 5. So I'm going to now get rid of the A and in brackets put a 5 raised to the power of 2. Make sure you say thank you to the B because the B was holding this spot for a number, and you now know what the number is, which is 2. So say thank you very much, B, but B, you're gone. And in your spot, I'm going to put a bracket and put that 2 raised to the power of 4. Okay? The most important part there is to say thank you on the way out because they did their job. Now, 5 to the power of 2 is 5 times 5 or 24. Sorry, 25. Next one, 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. And when we subtract those two, I end up with 9. All right. Is that good? Any problems there? One last thing I'm going to do with you guys before I get you working for a little bit here this morning, okay? One last thing. I just need you to understand what it means. And put your hand in the air if you're ready to move on. Okay, sorry, I should just make sure we're on task here. So just fire your hand up if you're ready to move on. Okay, overwhelming amount. So I just need you to understand what it means when there's a negative in a fraction, okay? So if you take a look at this, I want you to understand what this means. This negative right here is one negative out front. So I'm going to write it over here, and if you want to, you can write this too, just as a little side note, okay? But here's what this means. When you have a negative out front of a fraction, and let's just call this fraction 2 over 3, just like the one we have. This is the equivalent of the following. You have a fraction and you have the negative up top with the numerator, but not in the denominator. You see how there's just the one negative still and it's up in the numerator? Or you have a fraction with 2 up top, no negative, and the negative goes down to the bottom. But you see in every one of these cases, just let me drag this down here. You see in every one of these cases, there's only the one negative. These are all equivalent. Negative out front, 2 over 3, equals a negative 2 up top over 3, or 2 up top with a negative 3 down below. Now, this one here, you can put this in your notes. We rarely ever use this one right here. We hardly ever put a negative down in the denominator. The reason being, it's a lot harder to find a common denominator when you've got a negative down there. So don't put the negative in the denominator. This one is almost kind of, and I'll highlight it out here. This one is almost ignored. We don't use this one right here at the end. This green one, we don't really use ever. But these two we do. But when we're doing calculations like we're going to do here, raise this to the power of 5, we always tend to use this middle one and we put the negative up top. Okay, so our next step in solving this here, before we get to doing the following, do you remember on the front page? Do you remember doing the exponent right here? Before we get here, we always just take that negative and we pop it up into the numerator. We rewrite it. This does not mean that both are negative. Do you see that negative here? It does not mean -2 over -3. It's just one or the other. You have to understand that, okay? So when I take my calculator, this may be one of the more important things you see today, okay? If I go negative and then open up a bracket and go 2 divided by, and I'm going to go 3. Do you see how I get this -2 over 3 or -6 repeating? You see how I get the negative? They're all negative. If I were to change this and I take the negative and put it up in the numerator, so here's a fraction, -2 up top, 3 goes down below. Oh, delete, down below 3. And I hit equals. Do you see how I still get the equivalent fraction with the negative out front? And I can switch around and they're all the negatives, just like we had before. These two are equivalent. But as soon as I go like this, watch what happens. -2 down below -3. And when I hit equals, watch what happens. The negatives go away. They cancel each other out. It's a double negative. If I tell you it's not going to not rain, that's a double negative. It's not going to not rain. Well, that means it's going to rain. Take a look here. It's not going to not be 2/3. It's not going to not be 2/3. Guess what? It's going to be 2/3. It's a double negative. So when you have a question like this here, don't put negatives on both. Don't put a negative down below here too. On the 3. Can't believe how slow this is sometimes. Don't put the negative down there with the 3 also. Just keep the one negative up in the numerator. Now here's what we can do. -2 gets raised to the power 5. Make sure you put brackets around that -2 because it's all the -2 being raised, and we don't want to run into this problem right down here. Do you remember this problem right here between these two? Make sure you put the negative in brackets. So we have -2 to the power 5 all over 3 to the power 5. And in our calculator, we can go -2 raised to the power 5 in brackets. And if you trust me, you'll get -32. Down below, you will get, which is 2. And if you would do you see the original question, how they had the negative out front? But in order for us to do this question, we put it up in the numerator. Now that we've gone through and we have this negative in the numerator, why don't we just bring it back out and put it in front of the fraction and just write it as this. This right here tells me you are very confident with how the negatives work, how a fraction works. You move the negative up to the top. We figured out our value, and now that the negative's up top, we're just going to bring it right back out front again, and you're done. All right, is everybody good? Any problems there? Talk to me here. Any problems?
No, sir.
No.
Okay. Now, I did something new this year. So almost everybody except Connor, Luke, and Heidi until next week. You guys should see right after this page, do you see 2 lined pieces of paper with the questions 1 to 10 from 114?
Yeah.
That is your work right now, but because you don't have a textbook, you guys will have to do the following, okay? So follow me here. Everybody can be doing this. We're going to be going to Edsby, and we're going to have to open up chapter 3. So we'll go to our Edsby page, we'll go to that library, we'll open up our textbook, and we'll open up chapter 3, which is polynomials. Come on. Rowan, I feel your pain. So slow here too. I think all the teachers are teaching right now. So if we go to one of the 2 to your page, go down to library, you see right here, and you click on the folder, it will open up a new window with all of our textbook chapters. But we want chapter 3, which is polynomials. So on your device, your laptop, your computer, your phone even, what you're going to do is you are going to scroll down to page 114. Work with exponents. Here it is. This is the chapter we just went over all the way through. Here are the key concepts right here. Kind of reviewing the key concepts. And then you see on page 114 right here, you're going to do questions 1 to 10. Okay, the first one shouldn't be too bad. And let's go through the first ones together. Okay, let's just go through the first ones together here, some of the multiple choice and stuff. So question 1, which is 6 times 6 times 6 times 6 written as a power? In the side, type in your answer. A, B, C, or D. What is 6 times 6 times 6 times 6 written as a power? If you're confident enough, see a lot of B's coming in. That's correct, right? This is expanded form. This right here is exponential form. So the first one's good. Awesome. What about the next one? Which is 3 to the power 5 written in expanded form? If we want to write that in expanded form for 2, question 2. Awesome. I see a lot of C's flying in here. That's great. We take our base, which is 3, and we raise it to the power 5, which means 3 gets multiplied by itself 5 times, and that is in fact C. It's not A, it's not multiplication, just 3 times 5. It's 3 times itself 5 times. Awesome. So we then go to 3. You can write 3 in expression as a power, so you can write each of these as a power. In 4, you can write them in expanded form. And then 5, 6, 7, 8, 9, 10, you have some evaluations to do just like in our note, okay? So I'm going to give you 45 minutes right now in order to work on this. And I do want you working on it because we're going to take this up after, okay? This is time for you to work. I'll put a timer up for 45 minutes and we'll reconvene after 45 minutes. Do not leave the Teams meeting. I'm going to stop the recording right now so I can post this, but I want everybody